Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. In Algebra 1, we had like an intro session last time. I think it was on Friday. And I thought about, trying to complete the course, but I thought, there are stuff that you will learn easily in school, like, for example, the type of different types of numbers that we are going to deal with. What's the difference between a real number, an integer, a natural number, and so on and so forth. And I said it's a waste of time to spend time on that. You should, I think you already know most of this stuff, or you will learn it very early in your school year. So maybe I thought of starting with also a very easy lesson just to get you rolling and getting more confidence that you really can do this stuff. It's very simple. With minor things, like with minor vocab words in math or in algebra, you can easily solve these types of problems. So we will start with what we call a one-step equation. So what is a one-step equation? One-step equation, as the name implies, you need only to apply one step and you get the answer. It's so simple. One-step equations. Remember, equations meaning I have an equal sign, a right-hand side and a left-hand side. Typically, not necessarily, but typically, we want to have the variables on the left-hand side and the constants on the right-hand side, and then we apply the inverse equation, meaning if I had something originally, let's take an example and then I will explain it as we go. Very simply, suppose I have something. So in this case, I would place the variable on the right side, not the left side. It really doesn't matter. You can switch them, or you can solve the problem and leave the variable on the right-hand side. So it's up to you. It's a matter of taste from my point of view. I prefer to have the variables on the left-hand side to be consistent, but there is nothing preventing you from solving it the other way around. Like you will see. For example, here I would write any number, let's say negative 5.8 equals, and then I'm going to select a symbol or a letter for my variable. And since my name starts with M, I'm going to say M, and then maybe plus 4.1. And I want to solve for M. Notice, I can do the following, and many students would prefer to move things to the left-hand side. Oh, I'm sorry, what happened? I think I clicked a button to change the screen without noticing. So some people would say, oh, I want the M on the left-hand side and the numbers on the right-hand side. So let me subtract M from both sides. Notice this is a balance. So if I'm going to subtract M from the left-hand side, I will subtract M from the right-hand side. And I do that, and I find I have a negative M, not an M on the left-hand side. I say, oh my God. And then I start working, I panic, I lose time. If you prefer to have the left-hand side on the right-hand side, just rewrite the equation like that. Simple, right? Whatever was here, if you have two sides of a balance and you have a weight on one side and maybe a bag of sugar on the right-hand side, you can switch them and you still will have a balance, right? So this was the bag of sugar. I moved it to the left, and the weight, of course, the weight will not be negative, but I'm just giving an example. I move it to the right. I don't see why not keeping it on the right. So again, these minor things, I don't want you to be, to memorize stuff. Oh, I learned to have the variable on the left and no, there is no such thing like that. It's whatever you feel easier for you. Let me solve it if it were like that, and then show you it's the same and exactly the same way if you move them around. So here I'm going to say I am solving for m. Oh, I'm lucky. I don't have m multiplied by anything. It's m by itself. So I want to get away from everything else. What is the everything else that we have? Yep, absolutely. The 4.1. And it's added. There is a positive sign. And I learned that the opposite of addition, or we call it the inverse of addition, is subtraction. So I'm going to subtract 4.1. That's the first thing I do. And then I said, oh my God, that balance will not be now level because I took away from the right-hand side, the left-hand side would be heavier. So I have to subtract the 4.1 also from the left-hand side such that I get a balance again. Now what I did is I got rid of the 4.1 on the right, and then I have a negative 4.1 minus 5.8 for a total of negative 9.9 equals m, which means m equals negative 9.9. Here it's the same thing. I would have subtracted 4.1 from both sides, and I get the same exact answer. Now, some people have trouble with addition and subtraction. I mean, it's okay. It's okay if you don't understand why. So for example, I'm going to show you maybe 4 questions. What if I say 4 minus 2, or negative 2 plus 4, or negative 4 minus 2, or what? Negative 4 plus 2, for example. Everybody are familiar with the first one. 4 minus 2 is 2, right? So what is negative 2 plus 4? Yes, you heard something called the commutative law. Then whether I put the 4 first or last, and if I put the negative 2 last or first, it's the same thing. You can rearrange them like we rearrange the right-hand side and the left-hand side here. Same concept, but not exactly the same way. I can say 4 minus 2 is also positive 2. When I have two numbers that are both negative, I will place the negative sign and assume they are positive because I already took the negative from them. And I say 4 plus 2 is 6, so negative 4 minus 2 is negative 6. But if one is negative and the other is positive, like this case, I would say, okay, which one is the larger, the 4 or the 2? The 4. So I start, and the sign of the 4 is negative, so I write negative. And because they have different signs, negative and positive, I subtract, I say 4 minus 2. 4 minus 2 is 2, but since the negative was bigger, it's a negative 2. So that's one way to do it. Another way to do it is to think of a number line. Maybe I don't have enough space because we have a negative 6 here. Okay, negative 5, negative 6. We start always at 0, and we start always facing the positive. So I am standing up here facing the positive. Excuse me. So what happened? What happens, I'm going to say, okay, if it tells me 4, I'm going to move forward 4 units. So I go to 4. And then minus, meaning I will start walking backwards, right? Don't try that at home. So I'm going to move 4 units to the right, forward because I'm facing right, and then I'm going backwards 2 units. So I stop at 2, which is 2. Or I could have started here, moved 2 units to the left, and then 4 units to the right, I also get a 2. If I'm here and I move backward 4 units, and then backward again 2 units, I will end up at -6. And if I start here and move 4 units to the left or backward, and then 2 to the front, I end up at -2. And then after a while, when you try one of these two methods, this one is very easy, it becomes a habit. You don't need to draw a number line. Of course, you don't do that. You do it in your head, and if the bigger number is negative, my answer would be negative. If the bigger number is positive, my answer would be positive. If both are positive, my answer would be positive. If both are negative, my answer would be negative. Okay? So, or you can think of it from the point of view of money. I earned $4 and I spent 2, so I'm left with 2. I spent $2 and then I got $4, so I end up having 2. I spent 4 and then I spent 2, meaning my money has decreased by $6. I spent 4 and then I received 2, so I find my money has decreased by $2. Okay, but having said that, this is just for, if I have -4.1 and -5.8, how do I add them? Yes, you move to the left 4.1 and another 5.8, so you move to the left altogether 9.9 units. Okay, let's take another problem that has a proportion or a ratio on one side, not a proportion, a ratio. So let's say ratio starts with R, so I'm going to say R divided by, for example, 3.8 equals a negative number, maybe -3.5. And I'm solving for R. R is already on the left, so thank God, I'm not going to move things around. But it's divided by 3.8. I wanted R by itself, but R is divided. So to return it back to R, I have to apply the inverse of division, which is multiplication. So I'm going to multiply the left-hand side by 3.8. I'm using the times, not an X, just for you to understand it. Some people prefer to use parentheses. And I'm going to say times 3.8 or 3.8 between parentheses, doesn't matter. Now you see in the left-hand side, the 3.8 divided by 3.8 is 1, so the left-hand side is only R. The right-hand side is negative 3.5 times 3.8. This is what? So it's like 13.3 or something. 3.5 times 3.8. Yes, it is 13.3. Here, I had something added to M, so I subtracted it. Here I had R divided by something, so I multiply by that thing. Always apply the inverse. Let's take another example. Let's say now instead of being multiplied, instead of being divided, it's multiplied. So maybe if I have a number, so my variable is S, okay? And let's say I multiply S by 7.2, and I get 43.2. And I would say, okay, my variable is on the left, that's good. That's my variable S, but S is multiplied. Remember when I told you last time that if I don't see an operator between the number and the variable, it means It's a multiplication. We don't write X, we don't write point, but we just leave it blank. Notice here also, I have a number and then a parentheses. No, is that addition? Is that subtraction? No, it's multiplication because I didn't write anything. If I say plus, then these are added. If I say minus, they are subtracted. If I say divided by, it's division. But when it's multiplication, I don't write anything. Okay, so we always see an embedded or a hidden multiplication sign where one's supposed to be and nothing exists. Okay, so this number is multiplied by s, and I want to separate s by itself. The opposite of multiplication is division, since the opposite of division is multiplication, right? The inverse. So I'm going to divide both sides by 7.2. 7.2 divided by 7.2 is 1, and 1 times s is s. Yeah, some people write 1s, but the 1 has no meaning here, right? So I say s equals, and then I divide 43.2 by 7.2, that's 6, right? 43.2 divided by 7.2 equals 6. So s equals 6. Maybe the only thing not the only thing, but one thing we haven't done is to have fractions on both sides. Okay, so let's take one and let's say maybe a fraction, we can call it f for fraction. And let me put it on the right-hand side. So let's say, for example, I have 7/12 equals a quarter plus f. What is f? Again, people who don't like the variable in the right-hand side, write it as 1/4 plus f, or even f plus a quarter equals 7/12. That's what you are most likely familiar with. In this case, again, my variable is f, and I have something added to it. Notice we don't write plus in the beginning. If it's a number in the or a variable as the first entry, we don't write plus. There is a hidden plus sign here. Positive f plus 1/4 equals positive 7/12. We mentioned also that we don't write the plus sign if it's in the beginning, right? But we know it is positive. Okay, so now since it's added, I want to subtract it, right? So I have to say minus a quarter and negative a quarter. Notice now the 7/12 is no longer the first entry, so I have to say plus. Or I could have left it, and like here, I could have said here, subtract 1/4 from both sides. And since now the 7/12 is still in the beginning, I don't need to add the positive sign. And now I face a problem. What is 7/12 minus a quarter? They don't have the same denominator. So what do we do? Yes, we use the least common multiple of 4 and 12. Luckily, it's 12 because 12 is divisible by 4. If you are old like me, every time I see numbers that have a denominator of 2 or 3 or 4 or 6 or 12, I always think of my wristwatch, my watch, because it was, divided. Or if you look at the wall clock, if it's not digital, you see, the minutes hand goes through 12 units every hour. And we know, just because we are used to that when it's at 3, we say it's a quarter, at 6, it's a half, at 9 is 3/4, and so on and so forth. So when I see problems like that, it doesn't take me a second to see that here there are 12 numbers, right, around the clock. And when the minutes is at 7, I can see it, right? And they say, I see that a quarter of an hour is at 3. So now it's like I have 7 over 12 minus 3 over 12 is 4 over 12. And 4 over 12 is 1/3 of an hour. So I know that these two add up to a third. Don't have to worry about that. I was just telling you. Now I know that the common denominator is 12. So F equals over 12. 12 divided by 4 is 3. 3 times -1, not 1, is -3. Plus the 7 is already over 12, so I don't need to do anything over it. And now I can switch them for those of you who like to see always the variable on the left-hand side equals 4 over 12. And now 4 and 12 are both divisible by 4. So divide by 4, you get 1. Divide by 4, you get 3. So F equals 1/3. If you want to write it as decimal, it's 0.333 or 0.3. Repeat. Okay. So maybe we can have like a written problem. So we haven't done one like that, but all of these are one-step equations, and you should be very familiar with those, and they are so easy. And we always start with easy stuff, not to mean that the next stuff or the rest of the course is hard. This math courses are very easy if you know if you have a good foundation, meaning these things you're already familiar with them. We don't waste time solving problems like that. We know how to do it very fast and very efficiently. Okay, that's the key. Okay, so now we have a piece of land. It's rectangular. The reason I make it rectangular is that you know the area of a rectangle. And in a previous video, I think for maybe 7th or 8th graders, I did one on how to calculate areas and volumes. You can, refresh your memory if you need to by watching that. But if you are familiar with it, you don't have to waste your time. Suppose we have the width of this land, let's say it's a 14 meter. And then I have the total area is 630 square meters. And I want to know the length of the land, this piece of land. What is its length? Now I need, first of all, I don't know the length. So I have to use a letter for that. Some people always use X, okay? Some people use the first letter, okay? It's up to you. So if you say, you have to tell me, this is a key here. This is not a common mistake, but a common confusing things for students saying, well, in this case, everybody will write it correctly, but you have to make it specific. You have to say, let, for example, X or L be the length of the piece of land or of the rectangle. And I know the width is 14. Area of a rectangle equals length times width. The length, I already created a variable for that. So I'm going to say X times, and the width is 14. So I could say equals 14X, right? We don't write the times between them. And usually we write the number, not usually, we have to write the number before the variable. I cannot say X14 because X14 may be another variable. I have X1 and X2 and X3, and I have X14 and I have X31, whatever. So you write the number first. You don't write any operator between it and between x so that I know that the area is 14 times x. But the problem is telling me that's the area of a rectangle. And the area of the rectangle, it's given to me as 630. So instead of area of a rectangle, I write 630. Yeah, that's too early, right? 630. Okay. So now, oh my God, I got this problem back. 7.2s equals 43.2. 14x equals 630. I made it a very simple problem. And then I would say x here is multiplied by 14. I want to separate the x. And some people will first switch right and left. It's okay, I don't care. And then I'm going to say, okay, it's multiplied by 14. I want to separate them. So I divide both sides by 14. So the left-hand side is x, and I divide 630 by 14, okay? Which would be what, 45 in this case? I think so, yeah, 45 meters. Notice the units are extremely important in math, science, engineering. You cannot say just x equals 45. Nobody would understand. What do you mean 45 what? Inch? Mile? Millimeter? I don't know. So you have to enter the units. Okay, I think this was a very simple and easy session. Maybe next time we'll look at what if we have two variables and we need to solve a problem using two-step equations. Why do we need two steps and how do we do that? See you next time. Have a great day. Bye.